Hello, everyone, and welcome to the fourth session of the Snowflake Educational Series powered by BluePi. My name is Tanika, and I will be your host for today's session. In case you have missed out on the previous sessions, please check them out on our YouTube channel, and you can find the link to the same in the chat box. Now, I'd like to introduce today's presenter, Ayushi Kaushik. She is a senior big data engineer at BluePi and has been working with us for the past 1.5 years. She has prior experience working with data warehouses and ETL, and she will be talking about data sharing. Data sharing is providing partners with access to information they cannot access in their own data systems. It allows stakeholders to learn from each other and collaborate on shared priorities. Data sharing encourages more connection and collaboration between researchers, which can result in significant new findings within the field. In today's session, we will learn how Snowflake allows us to share data securely and efficiently. Along with Snowflake's secure data sharing capabilities with the data clean room, we will also have a sneak peek into the Snowflake's marketplace. There will be some polls going live between the session to test your knowledge. The participant with the most correct answers will receive a shout out at the end of the session. I hope you guys enjoyed the session. Over to you now, Ayushi.
Thanks, Tanika, for the introduction. A very good afternoon to everyone, and thank you for joining me today. Welcome to the fourth webinar of Snowflake Educational Series powered by BluePi. Today, we will be discussing how we can share data on Snowflake securely and efficiently. Let me just share my screen and move to PPT. Before diving in, I would like to navigate you through the platform. On the right-hand side of your screen, you will see a Q&A tab. If you have any questions during the session, you can post those questions on that tab so that I can pick them during the end of the session. Also, you will find the polls running throughout the session there only. Now, in previous sessions, we discussed Snowflake functionalities and various capabilities, its architecture, and how it provides high availability and disaster recovery. In case you have missed those sessions, please find out the YouTube recordings available on our company's channel by the name BluePi Consulting. You can also find the link on our LinkedIn page. In today's session, we will talk about how we can share data between different accounts using Snowflake's secure data sharing, Snowflake's marketplace, and data clean room. Secure data sharing enables sharing selected tables, views, and user-defined functions in a database from one Snowflake account to another Snowflake account. With secure data sharing, no actual data is copied or transferred between accounts. All sharing is accomplished through Snowflake's services layer and metadata store. This is an important concept because it means that the shared data does not take up any storage in the consumer account and therefore does not contribute to the consumer's monthly data storage charges. The only charges to consumers are for the compute resources, which are the virtual warehouses, which is used to query that shared data. Also, these shared databases cannot be reshared with other accounts. Now you will see a poll coming up to refresh your knowledge. Please participate in the polls. Now let us see how Snowflake's secure data sharing is different from others. In Snowflake, data sharing is live, which means the instant data is populated in a table which is shared. It is instantly viewable by the other Snowflake account thus table has been shared with. The row access policy on the shared publisher data table ensures that the live content is only viewable by approved queries. There is no specific ETL job required. We can share personalized data, which means we can share relevant data to a particular use case to the right person with the right role. Also, we can share business logic related to that data. And Snowflake also support data sharing across cloud and region. Data is very well governed and access can be revoked anytime within couple of minutes. Now in Snowflake, secure data sharing is achieved through shares. But what is a share? Shares are named Snowflake objects that encapsulates all of the information required to share a database. Each share consists of the privileges that grant access to the database and the schema containing the objects to share. Each share also consists of the consumer accounts with which the database and its object are shared. Once a database is created from a share in the consumer account, all the shared objects are accessible to the users in the consumer account. Shares are secure, configurable, and controlled 100% by the provider account. New objects added to a share become immediately available to all consumers, providing real-time access to shared data. Access to a share or any of the object in the share can be revoked at any time. Now, if the objects to be shared are in one database only, a share can be created for that database and access to all objects can be given. But if objects are in multiple databases, like this as shown in figure, then we need to create a view from multiple databases and then create a share for this view. And in this way, objects from multiple databases can be shared. Now let us see some general limitations regarding these shared databases. Shared databases are read-only. Users in a consumer account can view or query the data, but they cannot insert or update data. They can also not create any new objects in the database. The following actions are not supported. Creating a clone of a shared database or any schema or table in the database. Time travel for a shared database or any schema or table in the database. Editing the comments for a shared database. Shared databases and all the objects in the database cannot be forwarded, which means they cannot be reshared with any other account. So, only the roles used to create a database from a share in the consumer account can use the database initially. However, access can be granted to other roles through a special data sharing specific privilege, which is named as imported privileges. A role can grant imported privileges on an imported database only when either it owns the imported database or was granted the managed grants global privilege. Creating Snowflake streams on shared objects, secure views or tables which are shared, enables you to track data manipulation language changes made in those objects. This functionality is similar to creating and using streams on local objects. Now you will see another poll coming up right over there. Let us now look at the steps needed for sharing data securely in Snowflake. Step 1 is the provider creates a share of a database in their account and grants access to specific objects in the database. The provider can also share data from multiple databases as we discussed earlier in this slide. Then step 2 is one or more accounts are then added to the share, which can include your own Snowflake accounts or multiple Snowflake accounts. Then in this step 3 on the consumer side, a read-only database is created from the share. Snowflake does not place any hard limits on the number of shares you can consume from data providers. However, you can only create one database per share. Access to this database is configurable using the same standard role-based access control that Snowflake provides for all objects in the system. Now, there may arise a situation when a company wants to share data with some vendors who are not already Snowflake customers, without requiring the consumers to become Snowflake customers. So in those cases, a reader account can prove to be helpful. But what is a reader account? A reader account, formerly known as read-only account, enables data consumers to access and query data shared by the provider of the account without any setup or usage cost for the consumer. There is no requirement for the consumer to sign a licensing agreement with Snowflake. The reader account is created on and managed by the provider account, which assumes all responsibility for credit charges incurred by the users in the reader account. Similar to standard consumer accounts, the provider account uses shares to share databases with reader accounts. However, a reader account can only consume data from the provider account that created it. Now you will have another call to refresh your knowledge, and let us jump into action and see a live demo of sharing data in Snowflake environment. So for demo purpose, I have two accounts, party 1 and party 2 account. Party 1 wants to share its employees data which is present in a database named data sharing demo with party 2. So for this, as I told, we need to create a share. Let's go in outbound share and create one share. This share is for employees data to party 2. Here we can select the database which we want to share. This is a single select option, which means we can only select one database. After selecting database, we have the option to select various objects in this database. This is a multi-select option. We can select as many objects as we want. In the current scenario, I want to share only the employees data table. So I will unselect the customers data. Apply. After giving permissions to the objects in the database, we can create this share. Here we can view the table we want to share. So this is the table that I am sharing. Next step includes adding consumers. Here we have two options. Either we can add a reader account or we can add a full account. Now party 2 is already a Snowflake customer. So we will add a full account, and here we need to provide party two's account identifier. Let us move to party 2 account, and here is the account identifier of party 2. Let us move back to party 1 account and provide party two's account identifier. So as you can see, one account has been added successfully. Now, the step 3 was moving to party 2 account, finding that share. We will see it in inbound share. Here you can see employee data to party 2. This is the share created by party 1. Now we need to create a database from this share. For creating a database from a share, your role should be of account admin. Currently, I can cross check that my role is account admin, so I can proceed to create database from this share. I can name the database whatever I want. Then I can give access to certain roles. This is also a multi-select option. Here you can select multiple roles and then you can create this database. Now if you go and check your list of databases, refresh it, you will be able to see that the database we created is now visible here. Let us try to access the table share. So here you can see I am able to access that table from party 2. So this is how easy it is to share data between two Snowflake accounts. Now let us see if I can delete or insert in this table from party 2's account. It gives me an error that insufficient privileges to operate on the table employees data. So this is why we are saying that shared data is read only. We can neither insert nor delete. Now, suppose party 1 wants to stop this sharing. So it will select this share and drop it. And as soon as party 1 drop the share, party 2 will not be able to access this table any longer. It shows the error shared database is no longer available for use. It will need to be recreated if and when the publisher makes it available again. So this is how easy it is to revoke the access to the shared database. Now, let us consider the scenario when the consumer party is not a Snowflake customer. In that case, from party 1 account, we will have to create a reader account. For creating a reader account, I need to go to account, reader accounts, and here I need to create a reader account. I will give it an account name for my reference. Then I can give a username and password. And then I can create this account. Snowflake takes around 30 seconds for this account to be created. This is the account identifier of this reader account. After creating this account, we can share it with our consumer party and they can access the data through this account. So here you can see the reader account has been created successfully and we have also got a URL to log in. Now let us create one more share which will provide. Okay, so we have created this share and this time we will add the reader account as the consumer. This is a multiple select option and here I can select as many reader account as I want. So after adding it, I need to go to that reader account's URL and I need to log in and create a database from the share created by party 1. So after just logging in into the reader account, it will ask you whether you are a data provider or a data consumer. In current scenario, I am a data consumer. Now here in the list of shares, I will need to change my role to account admin to have a look at the shares. Here you can see I am able to see the share created by party 1. Now I can create a database from this share, provide access to the required roles, and then create database. Now if we go in database list, we can see the database shared by party 1. So this is how easy it is to share your data with any non-Snowflake customer as well. Now let's move back to our presentation. Okay. Now let's talk about Snowflake Marketplace. It is a platform to discover, evaluate, and purchase the data. The Snowflake Marketplace utilizes Snowflake secure data sharing to connect providers of data with consumers. You can discover and access a variety of third party data and have those datasets available directly in your Snowflake account to query without any transformation. And then we can join it with our own data to drive more business insights. You can also become a provider and publish data in the Snowflake Marketplace, which is an attractive proposition if you are thinking about data monetization and different routes to market. Snowflake Marketplace is available directly from your Snowflake user interface and enables every Snowflake customer to discover live data from a variety of providers. This data is live in the sense that if the providers of data update it, it will be instantly available in our account as well. Now, if you have to get this data without the data marketplace, you would need to find a vendor who has the data which you require for your use case. Then you will get some CSV files and you will need to create some ETL jobs, and it will take around days till you can query that data. But using Snowflake Marketplace, you can do this in a couple of minutes. Let us move to demo of Snowflake Marketplace and have a look at how easy it is to get data from third party. Now, since Snowflake Marketplace is a new feature, we can only access it from the new UI of the Snowflake. After moving into the Marketplace tab, we can see different data listings from different providers, and these data listings have been categorized into many categories like financial, commerce, and many more such categories. If you are interested in becoming a data provider, you can get in touch with Snowflake's support team. Here we have some filters where we can filter the data listings based on categories, business needs, or the providers. Let us suppose I want to compare my company's sales data with COVID outbreak to drive any insight related to COVID. So let me search COVID. All the data listings related to COVID will come. Here I can choose from anyone. Let us open this. This is provided by Star Schema. Here I can see info about the data. I can also see the columns provided in the data. I can also have a look at the sample queries provided by the provider of the data. After reading all this, if I feel that this is the data that I want, I can request to get this data. Now this data is free of cost, but there is also some data listings which are paid. As I request to get this data, I can see that the data has been added in my account. So this is the data that I requested. Yeah. So these are the tables. Now I can query these tables. Now let us move back to our presentation. Now let's talk about the most interesting topic of today, data clean room. So sharing data while adhering to privacy regulations has always been challenging. But if we know which customers saw our advertisement and later bought products, then we can understand if we are getting a return on our marketing expenses or not. While these types of attribution analytics have happened in the past, the new Consumer Privacy Act and many regulations now block or complicate this analysis. But by using data clean rooms, it is now possible to collaborate with data in a secure manner that aligns with privacy rules. Data clean rooms control what data comes in, how the data is joined with other data sets in the clean room, and what types of analytics each party can perform, and what data can be exported. A clean room is not necessarily a room at all. Traditional clean rooms require physical infrastructure. Others rely on a trusted third party. But just give me a minute. Yeah. So, modern data clean rooms are not physical spaces. They do not require moving data into a different system or environment. In fact, that is one of the advantages of Snowflake. Your data does not need to be moved, it can remain secure and governed within your own Snowflake environment. Snowflake Data Clean Room is a framework or design pattern for secure multi-party collaboration leveraging core Snowflake features. In other words, if you have got an enterprise or business critical Snowflake account, you have got everything you need to deploy a Snowflake data clean room. Now you will see another poll coming up right your way. Let us try to understand data clean room with help of an example. In 1980s, a computer scientist and computational theorist, Andrew Yao, posed a secure multi-party computation problem, which is today known as Yao's millionaires problem. So this problem discusses two millionaires, Alice and Bob. They both are interested in knowing which of them is richer without revealing their actual wealth. So they want to share the data to know the underlying information, but they do not want to actually show how much their wealth is. Bob uses Snowflake Data Clean Room to allow Alice to compare her wealth with his without revealing the underlying personal information, which is their actual wealth. So Alice creates a table with her wealth value named as alice.wealth. Similarly, Bob creates a table with his wealth value bob.wealth. But then Bob creates an access policy that specifies exactly which question Alice can ask and what answer she can receive. In other words, Alice cannot ask what the wealth value is. In an SQL environment, that may look like this query. But since Bob has not allowed such type of queries to run on his data, it will give no result. So Alice can only ask about how the two relate to each other and get the answers that Bob has specified. For example, prior to setting up this data clean room, they both discussed and Bob finalized this query as an approved query. So when Alice will run this query, it will run because Bob has approved this query. This enables Alice's data to be compared to Bob's but without her sharing her wealth value and without Bob sharing his. If Alice tries to ask anything other than the allowed queries, she will get no result. This is precisely what a data clean room is. Now, of course, companies do not want to compare their wealth, but there are many other use cases where data clean rooms can prove to be helpful. The capabilities of data clean rooms are especially beneficial to advertisers and the media industry as we continue moving towards a cookie-less future. The most popular use case of data clean rooms is to link anonymized marketing and advertising data from multiple parties for attribution. Data clean rooms don't allow data points that could be tied back to a specific user to leave the environment, giving organizations the ability to adhere to privacy laws. But why should we trust Snowflake for these use cases? The data clean room functionality provided by Snowflake are secure. In it, personally identifiable information (PII) is anonymized, processed, and stored in a compliant way. These data clean rooms are really easy to implement. There are some specific templates of query which we will see in some time. These queries allow joining or overlapping data without moving or showing the actual data. And these data clean rooms are also very powerful. We can query large amounts of data of multiple companies in one single place. Now it's important to distinguish between traditional data clean rooms and distributed data clean rooms. With traditional data clean rooms, all data is stored in a single physical location, limiting how the data can be shared. With the developments of cloud technology, distributed data clean rooms eliminate the need to move data from one location to another, since now the data can live in the cloud. This allows each partner to control its own data while enabling governed analytics with other partners or even with multiple other partners simultaneously. Now let us see some features of data clean room which make them different from others. Snowflake data clean room can be multi-party. We can build a larger ecosystem of customers, particularly in ad campaigns. There is not just a single brand or media outlet. There is a complete ecosystem of agencies and partners and other third party data providers which come together to plan and analyze the data. Data clean rooms can also be cross region. We can execute this collaboration across regions. It is also multi cloud, meaning participating parties in a Snowflake data clean room can participate from a mix of AWS, Azure, and GCP platforms. This functionality is extended using Snowflake data replication between platforms but still follows the same data clean room deployment that we will be discussing. And it can also be cross instance. This gives us a lot of flexibility on how we structure the data clean room and how we execute this collaboration. Let us have a look at some of the use cases which where we can use data clean rooms. Brands can leverage their growing first-party customer data with third-party enrichment to define targets for marketing campaigns. Media companies can securely match their first-party subscriber data across their own platforms with brands' customer data to improve ad placement. Agencies or the advertisers or media companies themselves can combine campaign logs, identity, attribution, and sales data to measure the performance of an ad campaign. These can also be used to find lookalike segments to grow target audiences. And there are many more such use cases across multiple industries. Now let us understand the architecture of data clean room and how we can build one. So first we need to discuss the Snowflake features which help us build data clean room. Row access policies along with time travel functionality, using which parties can match customer data without exposing either party's PII. Row access policy is a schema level object that determines whether a given row in a table or view can be queried by a Snowflake role or account. We will use row access policies to secure publisher user data by way of an approved query list. And then time travel functionality of Snowflake helps to refer to a particular point of time in the allowed statement so that there is no narrowing around specific customers or data to get the better idea of the actual numbers. Then we have Snowpark and stored procedures. These helps to generate and validate query requests. A stored procedure enables users to create modular code that can include complex business logic by combining multiple SQL statements with procedural logic. Then we have secure data sharing. For automatically and securely sharing tables between multiple Snowflake accounts without the need for movement outside of Snowflake. Then we have streams and tasks. A stream object records data manipulation language changes made to tables Enter task object is a scheduled SQL code to run on a time-based schedule. We will use the combination on a share table from the consumer to poll for new entries in that table. Now let us see what are the precise steps to build our data clean room. So first we need to get a Snowflake account for each company or group that will be participating. Then we need to load data into Snowflake, which we need to share. Then we can use Snowflake secure data sharing to share data between the participants. Then after configuring secure functions and secure joins to protect the data, we can perform analysis on the joined data using standard analysis tools while respecting each party's privacy policies and boundaries. For demo purpose, I will be creating a two-party data clean room. Let us see in detail how we can do so. So, for creating a data clean room between two parties, the publisher party and the consumer party, we need to have some architectural objects in place, which are nothing but some tables which will be shared between both the parties. So, the publisher shares query templates table, which contain the approved list of SQL templates. These query templates are given descriptive names and then stored in the party 1 query templates table. Query templates typically include substitution parameters. For example, in this given query, the text after the symbol is the variable which will be replaced by some limited available values. The consumer can choose from this list of available values to substitute in the query template. This list of available values is stored in the party 1 available values table. Then we have request status table. After the completion of a query request from the consumer, the status is shared back to the consumer. If there are any error messages, they are also inserted in this request status table. Then we have publisher data, which is the live data that will be queried. For our demo, we have used Snowflake sample data, which is typically already present in newly created Snowflake accounts. And then there will be a table internal to party 1 named as approved query request. This table will not be shared, it will be internal to party 1 Snowflake account. A stored procedure on the publisher's Snowflake account is calling for new requests from consumer, and when it finds one, it validates it as a approved query, and then it inserts a fully formed query into the approved query request table. Publisher data is protected by the row access policy. Only approved queries which are present in the approved query request table can be used against this data. All other attempts to access party 1's customer data will come back empty-handed. Then on the consumer side, the consumer needs to create a query request table and set up a stored procedure. Whenever the consumer makes a request via this stored procedure to execute a clean room query, the request is lost in this query request table and instantly shared to the publisher. After this query runs, the results are stored in party 2's internal tables, which are not shared to party 1. The name of these tables is defined while making the request. The architecture pattern is repeatable, meaning that if there is a database that party 2 wants to share with party 1, then a consumer of a data clean room can become a provider by implementing the same pattern in reverse. Now let us see how the complete process takes place. So, an analyst from party 2 will call the stored procedure generate query request, which was created in the consumer account. This stored procedure will insert a record in the query request table, which will contain the details about which query template to use, which available values to replace with the substitution parameter, where to write the output, and some more details. Now, using Snowflake streams, the publisher's stored procedure, namely validate query, will run for this query. It will join query templates and available values table to form a fully formed query and then validate it. If denied, its status and error message will be written in party 1's request status table. If approved, it inserts a fully formed query into the approved queries table. It will also insert a record into the request status table, denoting the status of the request. One benefit of this stored procedure is that they can be reused for any table or any consumer and can be used to make multiple data clean rooms. As soon as the query gets approved, it will run on party 1's customer data and store the result in party 2's internal tables, which were defined while creating this request. Now, this was made possible when party 2 shared its query request table with party 1, and party 1 shared tables with party 2 using Snowflake secure data sharing. Party 1 also shared its customer data to party 2, but after applying some row level access policies to it. These row access policies allowed only those queries to run by party 2 which were present in the approved query request table. These are precisely those queries which were approved by party 1's stored procedure. Now these share tables by party 1 and by party 2 are what forms a data clean room environment. Ultimately, the responsibility for ensuring that the approved queries do not reveal sensitive third-party data is with the publisher in collaboration with the consumer, and this can be tested by the publisher and templatized for use by the respective consumer. Now, let's move into action and see a working data clean room. So, this is party one's account. So, here I can see that I have the tables which I discussed here. So here is available values table which contain the list of available values, a query templates table which contains the query which have been approved, and it also contains a name of that query. Then I have the request status table. It is empty. It will contain the status of all the requests made by party 2. And in the internal schema, I have the approved query request table which will contain the fully formed query request from party 2. Apart from this, I have party 1 customers data which has been shared with party 2, and from party 2 I have the share table query request. We can also go in party 2's account and see that all the tables are available here also. the party 1 share tables as well the party two's table. Okay. So now to create a request from party 2, we need to call a stored procedure generate query request. On calling this stored procedure, it will insert a record in the query request table of party 2. It takes in some arguments like customer counts, which is the table of the output, which need to be stored in the internal table of party 2. Then it contains the query template name, the name of the query template which we want to use for this particular case. Then it contains the available values which need to be substituted in the query template. Then it contains a point in time at which data is supposed to be queried. Then it contains a wait timeout period. So this wait timeout period is used because this stored procedure goes into a wait loop uh, until it gets an acknowledgement record from party 1. So this is after 5 seconds it will time out. After 5 minutes. Let us call this stored procedure and go to party 1 and call another stored procedure validate query. This stored procedure on party 1 will join the query templates and available values table and create a fully formed query and validate it. So here we can see it has finished query validation. If we move to party 2, here we can see the result of the validation. So here we can see the other party has approved the query request. Its results are now available in the table defined during calling. So we can access this output table and we can see that the output we needed has been stored in this table. So this is how easy it is to query the shared data in the data clean room. Now let us suppose party 2 wants to query again, but this time it wants to query the columns which have not been agreed on, which means that these columns do not are not present in the available values table. So let's see what happens in this case. So in this case, after query validation, we can see, so it has been approved. Okay. Let me just change this column name to a column name which has not been approved, like phone, which is a PII. So while setting up this data clean room, the both the parties did not agree on querying this column. So when we make this request and ask party 1 to validate it, it shows me that the other party did not approve the query request. Comment declined because field party1.phone is not available. So the only reason for declining this request was this column was not present in the available values table. So you can see that the consumer party cannot access PII or the restricted columns in any way. So this was how precisely we can set up a data clean room and we can utilize various Snowflake features to securely sharing data. Now, okay, so now I hope you enjoyed the session and it was useful for you. It's now let us give it over to Tanika. Okay, okay. So I see some people have asked some questions. Let us have a look at the questions. So Rishabh is asking, is there any credit limit on a reader account? Yes, Rishabh. The default credit limit of a reader account is 2000 per month, and it can be increased by contacting Snowflake support team. Next, we have a question from Anshita. Can we change data retention period for shared data? No, because as I told, time travel on shared data is not possible. We have another question. Um, in case of reader account, how is the credit usage charge? So the costing and every rules applied to the reader account are same as those applied to a normal Snowflake account, but they have to be paid by the provider account and not the users using reader account. Now we have last question from Gaurav regarding the allowed statements. Do they have to be perfectly identical, even the punctuations, blank spaces in the statement or not? So since we are not manually entering the SQL statement, we are using some query templates each time. So they will be identical almost every time. Okay, so this was today's session. Now, I request you to provide feedback for this session. On top right corner of your screen, you will see a pen and a message box. Please go there and provide feedback for today's session. I hope it was beneficial to you. Now it's over to you, Tanika.
Thank you, Ayushi, for such an informative session. So, if there are any more questions or for your valuable feedback, please feel free to mail us at the email address that was just shared. And also, please follow our channel on YouTube and LinkedIn for regular updates on these sessions. Thanks a lot for joining. Hope you guys enjoyed.